Hello everyone, welcome to my YouTube channel. This is Enoch's Tutorials. Don't forget to like and subscribe after watching the video so you can receive every bit of updates from this channel. In today's video, we're going to look at the gram staining procedure, which is a staining method which is normally used in the field of microbiology to differentiate between a gram-positive and a gram-negative bacteria. The staining procedure was first discovered by a scientist which was called Hans Christian Gram. So he used his name Gram to name the staining procedure. He was using this staining procedure to differentiate or to uncover the microorganism that causes pneumonia in microorganism, or let's say in human being. So he named the procedure gram staining procedure because it is basically used to differentiate between a gram positive and a gram negative bacteria. So a gram positive bacteria is a bacteria which has a very thick peptidoglycan cell wall. So gram-positive bacteria have a very thick peptidoglycan cell wall. We have two main types of bacteria. We have gram-negative bacteria and a gram-positive bacteria. Now the difference between them is that the gram-positive bacteria have a very thick peptidoglycan cell wall, whereas the gram-negative bacteria have very thin peptidoglycan cell wall. So their main difference is the thickness of their cell wall, which is made of a peptidoglycan layer. So for gram-positive bacteria, their cell wall peptidoglycan is very thick, whereas that of the gram-negative bacteria is very thin. So what is a peptidoglycan cell wall? Or what is a peptidoglycan as the name implies here? So the peptidoglycan is a polysaccharide which is made of a glycan sugar with some or being interlinked with some amino acids or let's say peptides. So it is just like a heteropolysaccharide which is made of glycan sugars. The glycan sugars are made of basically monosaccharides. It can be amino glucoses and the rest. They are made of polysaccharides, or let's say they are heteropolysaccharides made of the glycan sugars and interlinked with peptides. So this is the main component, or the peptidoglycan is the main component of a bacterial cell wall. So you have two main types of this. This one occurs very thick in gram-positive bacteria and occurs very thin in gram-negative bacteria. So that's how a peptidoglycan cell will look like, or let's say a peptidoglycan look like. So this is a structure of a peptidoglycan. It is made of a glycan sugar. So this is a glycan sugar. So an example of the glycan sugar is the N-acetyl glucosamine, N-acetyl glucosamine, and also N-acetyl muramic acid. So these are the two main glycan sugars found in peptidoglycan. Now these sugars are interlinked with peptides as seen here. So these are the peptides here. They are amino acid residues that interlink the glycan sugars in a peptidoglycan. So this is the main component of a bacteria cell wall. It is very thick in gram-positive bacteria and it is very thin in gram-negative bacteria. So this is the cell wall structure of a gram-positive bacteria. As seen here, it has a very thick peptidoglycan cell wall. So this inner layer of the cell wall of gram-positive bacteria is very thick. The outer is the lipoic acid or lipoic acid. The inner is the peptidoglycan cell wall, which is very thick than the main cell membrane. But in the gram-negative bacteria, it is very thin as in here. So in gram-negative bacteria, the peptidoglycan is very thin as seen in this diagram or in this structure. So the gram-positive bacteria is basically used to differentiate between gram-staining procedure is used to differentiate between a gram-positive bacteria and a gram-negative bacteria, basically based on their thickness of their peptidoglycan cell wall. So let's see. We are going to look at the procedures for gram staining. Now in gram staining procedures, we need some reagent for the procedure. And in gram staining, we need four main reagents for the staining procedure. The first reagent, which is called the primary stain, is a crystal violet. Some procedures use methylene blue for the crystal violet for the primary stain. We need what we call a grams iodine solution. We need an ethanol or any other decolorizer, being it an acetone or an ethanol, combination of ethanol and water, or combination of ethanol and acetone. You also need a counter stain, which is called a safranin. safranin. So these are the four main reagents which are needed in gram staining procedures. Now these are the reagents. Crystal violet, as shown here, it is violet colored. Gram staining is more of a yellowish or an orange colored solution. Gram iodine, sorry. The alcohol is basically 90% alcohol, not 100%. It can be a combination of an alcohol and water or an alcohol and an acetone. Then the last reagent is the safranin, as shown here, which is very reddish or purple in color. So these are the differential reagents which are used in gram staining procedures. So let's look at the procedure which is involved in gram staining. Now this is the main procedures in gram staining. Now if you want to differentiate or you want to identify if a bacteria is a gram positive bacteria or a gram negative bacteria, you have to apply the gram staining method to identify. Now the first method is what we call the smear preparation. So if you have the bacteria, just add an inoculum of the bacteria on a slide as in here. So just add an inoculum of the bacteria on a slide, then you smear it on the surface, then you slightly heat it to fix the bacteria on the surface of the slide here. So as we smear the bacteria on the slide, you heat fix by slightly heating or subjecting it to, let's say, a Bunsen burner to heat it to fix the bacteria smear on the surface of the slide. The main step here, which is the primary staining method, is the addition of the crystal violet. When you add the crystal violet, you allow it for some time to dry, then you rinse it with a distilled water, then you once again treat it with an iodine solution. You once again allow it to dry, then you rinse it for a while, then you treat it with an alcohol, which is an alcohol which is the solvent. After you add the alcohol, you rinse it again, then you do the counter staining, which is more like the addition of the safranin. Then afterwards, you rinse it again, then you observe it under microscope. So these are the main steps in gram staining. After smear preparation, that is, you just add an inoculum of your bacteria on the slide, then you heat fix the bacteria on the slide. Then the main step is the primary staining method. Now the primary staining method is you adding the crystal violet to the smear sample, then you add an iodine. The iodine in this case is called a mordant. It is called a mordant because it more of forms an iodine crystal violet complex on the slide. When you add the iodine to the solution or to this crystal violet added slide, it forms a mordant. And the mordant is a complex between the iodine and the crystal violet, which tends to, let's say, fix the crystal violet well in the cell wall of the bacteria. After you washing it again, you add the alcohol. The alcohol is termed as a decolorizer. So the decolorizer is just trying to wash away the crystal violet. It is trying to wash away the crystal violet. Now, the idea behind this one is that if the bacteria has a very thick peptidoglycan layer, when you add the decolorizer or let's say the solvent, what happens is the alcohol or the solvent can't wash the iodine. But if it has a very thin peptidoglycan cell wall, when you add the alcohol, it is going to rinse it off. Then when you add the counter stain, after rinsing, if the decolorizer washes off the alcohol or washes off the crystal violet, when you add the counter stain, then the bacteria will assume the red color of the safranin. In other words, if it has a very thick peptidoglycan layer in the case of the gram-positive bacteria, when you add the decolorizer, it can't wash it off. So even if you add the counter stain of the safranin and you wash it, you are going to wash away the safranin. That explains why after observation, we are going to see a gram-positive bacteria occurring violet under microscope, but gram-negative will occur safranin. A gram-positive is violet because it has a very thick peptidoglycan cell wall which takes up the violet color of the crystal violet. Hence, even if after decolorization, it can't wash it off. so it will still maintain the violet color of the crystal violet. For the gram-negative bacteria, on the other hand, they have a very thin cell, peptidoglycan cell wall. So after decolorization, you're going to wash off the violet color of the crystal violet. So when you add the safranin, it will maintain the red color of the safranin. So it will appear red, or let's say purple, under microscope. Now let's see. The step is very simple here. You just made your bacteria smear on the surface of a slide. You add a crystal violet. Then you wash it with distilled water. Then you add a grams iodine. Then you wash once again with water. Then you add the decolorizing agent. You wash once again with water and the decolorizer. Then you add the safranin. Then you get the final color of your bacteria. Here, the main idea here is, once again, the crystal violet is a primary stain. The iodine is a mordant because it forms a complex with the crystal violet. Then the safranin is a counter stain. It's a counter stain because it comes to counter the stain, counter the crystal violet stain. If the bacteria coming here is a gram-positive bacteria, before the counter staining, it will still be purple. But if it's a gram-negative bacteria, before the counter staining, it will be colorless. Hence, gram-negative bacteria will occur reddish under microscope because they will assume the red color of the safranin. What is well explained? Let's see. Now, this is the whole explanation of the gram staining procedure. So the gram staining procedure is very simple. It is just the ability of the peptidoglycan molecule to retain the violet color of the primary stain, or the crystal violet. That is the main idea. Now, gram-positive bacteria will retain the violet color when viewed under microscope because they have a very thick peptidoglycan cell wall which will retain the violet color of the crystal violet. Now, for gram-negative bacteria, they will not retain the violet color of the crystal violet, but they will assume, or let's say retain, the red color of the safranin, which is a counter stain, because when they are being decolorized or washed off with the decolorizer, they will become colorless. This is very simple. So this is just a summary of the whole procedure. Under observation, let's see, when you under observation, when you look at the bacteria under microscope, you are going to see bacteria or gram-positive bacteria occurring violet because the thick peptidoglycan cell wall has retained the violet color of the crystal violet. But gram-negative bacteria will occur reddish because their thin peptidoglycan cell wall cannot retain the red color or the violet color. Hence, when you decolorize or wash it off, it will go. Hence, when you add the safranin, it will assume the red color of the safranin. This is a summary of the whole process. For gram-positive bacteria, if it is colorless, when you add the crystal violet, it becomes violet colored. When you add iodine, it will assume the color of the iodine. When you decolorize, the ethanol cannot wash it off totally. So when you observe under microscope, it will occur this. For gram-negative bacteria, when you add the crystal violet, it will assume violet color. When you add iodine, it will assume the color of the iodine. Now, when you decolorize or add the ethanol, it is going to wash off the color of the violet or the iodine because the thin peptidoglycan cell wall cannot retain the color of or cannot retain the crystal violet. Hence, when you add the safranin and viewed under microscope, it is going to assume the red color of the safranin. Thanks for watching. Don't forget to like and subscribe to watching the video. If you want to receive updates from this channel, hit on the subscribe button and click on the notification bell so you can receive every update from this channel. Thank you.